Everyone. I welcome you all to the series of sorting algorithms. We had covered what was bubble sort, in which uh, every bigger number tends to move as a bubble to the last of the list. Today we are going to start selection sort. It's not that complicated, it's not uh, that difficult. It's simple mathematics, so not wasting much time. What selection sort is? We'll take the same example. Let me share my screen. Just a minute. Entire screen share. So we'll take the same example, same series, which was 2, 5, 3, 1, and 4. So in selection sort, our motive is the lowest one has to place itself at the first index, second, the next, and so that's why it becomes in ascending order. Whereas in bubble sort it was the highest one moving to the highest index. So talking about the same, that means here we have to start 25314. The ultimate goal that we have to reach is 1, 2, 3, 4, 5. To reach this goal, we'll start with this procedure. So this position we will call POS or position, because this is under consideration. The very next would be our J, which we will be used for the looping variable. J we will be using for looping variable. So this would be our starting position, and we have to make it minimum. The very next to it is variable J, which is responsible for the looping. We think the entire looping will go into it. So to make it more clear, pos is index at which we would insert minimum element. Min is index that holds the minimum element. So it will keep on changing as we move forward. If one is sorted, then minimum will be next, and so on. And J is looping variable. Before we move into the coding related things, let's see it how these things are done. So first of all, when 2 is at POS and min, 5 is J, the very first thing is POS. So POS is index 0, which is similar to minimum. Min is also index 0. This is our index 0. J is at index 1. So J is index 1. As far as L of J is less than L minimum. So Lj is the position we are taking into consideration. So if the list member of J, here it is 5, if it is less than the L minimum, here it is 2. So is it possible? Is 5 less than 2? So answer is false. This is not possible. I'll cross it. Similarly, next would be J would then become 3 and your minimum would become 5, so on. So our next would be now your 2, 5, 3, 1, 4. In this case, now you checked for J and compared it with L minimum and it was false. Now your L, since the value of J when 5, it was false. Now let's move to next, which is 3. Now L minimum is 3. So L of J should be less than L minimum. Do you think this is the case here? So L of J, L minimum is still 2, 3 less than 2. Again, it is false. So no swapping, nothing, no action being taken place. What about next? 2, 5, 3, 1, 4. Now your J is, the next one to 3 is 1. Your J is 1. Once your J is 1, your L minimum is still 2. Let's see if this satisfies the condition now. Lj minimum, is it less than L minimum? Answer is yes. Here 1 is less than 2. So it is true. So as soon as we see it is true, our next formation would be 1 getting here and our list goes on further. So now these get swapped 1, 5, 3, 2, 4. All these things, how many turns did it take? 1, 2, 3. In fourth turn, these got swapped. So we'll say for elements of 5, for 5 elements, we had 4 passes. So in general, for n elements, the passes would be n minus 1. Pretty much similar to how we saw it in bubble sort. So also when it is done, you have to do it for 4, and you know 4 is not less than 2. So swapping will not occur. It will stay as it is. That would be your fourth pass. So 1, 2, 3, and fourth. For 4, for 5 elements, you have 4 passes, n minus 1 pass. Similarly, you have to do for others. So here you have this sorted. Now you have number of elements 4. You will have 3 more passes. Similarly, when it is sorted, then 3, 2 more passes, and then 1 more pass, so on. Then you will be reaching to 1, 2, 3, 4, 5. Let's see how we do it in coding. So selection sort, the list remains the same. 2, 5, 3, 1, 4. N would be the length of. Now we'll talk about the outer loop, similarly to what we did in bubble sort. Outer loop is for number of passes. And how number of passes are decided. Here we will be using for I in range. So if there are n numbers, so list starts from 0, so the last number would be n minus 1. Last index is n minus 1. For I in range n minus 1, I have to define POS. So POS. So if we move back to our, so POS is first one, we'll take it as I. Similarly, minimum would be I for the very first thing. POS is I. Initially it is 0, then it will move to 1 and so on. Now for J in range I plus 1, it is auto completing for J in range I plus 1, and n is the last index, because if you are having I at n minus 1, J has to be at n. And once your sorting for I is completed, it will shift to next one. So that's why you are starting from I plus 1. If this is I plus 1. Again, similarly, L, J is less than L. We are not using POS here. Let us use L min. Min is J. And then if the condition is satisfied, LIL min will be swapped and we will get L min LI. Let's see if it works. All right, here you have to provide it. You're not providing pause, so you have written min in the places of pause. Min is there. Okay, pause should be there, but there should be would it indentation error, outer loop for number of passes. Typing error. N is length of L. Right brackets are used. Why it's not taking length? Ah, okay. Wrong use of brackets. Should work. So after selection sort, you are getting it. So here, your sorting is being done at I plus 1 n. Loop we are using n minus 1. Here minimum is, it's not 1. That's why it is taking 1 in the minimum. Now, you see, it shifted 1 from last to here, 25314. Next, why are we using I here? We are comparing it with minimum and positional. So let's see. Outer loop is this. Since we are not able to see what error our code is having, I would take help of chat GPT. So what does chat GPT says? Let's see. What is what is incorrect in this code? Then I'm pasting the code. Just the indentation. All right. So we have got the correction. There was a slight issue in the code. We were not taking into account the outer loop. We were focusing on the inner loop. So once it's sorted, looks like this. These are same. Indentation. It was not entering in this indentation from here. Let's see what's the result now. It's sorted, just the indentation thing. Because it was running just this loop, wasn't able to enter this loop. So just the uh, first pass, first thing, the inner loop was fulfilling, but the outer, it was not entering. With that, we complete selection sort. We'll have few more in sessions to come. Stay tuned, keep learning. Bye bye.